Hi, this is Dr. Hongdu. In this video, I'm going to explain the multiplication rule for dependent events. Let's get started with an example. Let's say we have a bag of marbles with 3 red and 4 blue. We're going to randomly draw 2 marbles sequentially without replacement. What will be the probability that both marbles are red? Probability rules can help us solve a lot of probability problems, but how do we know which one to use? To answer this question, let's see if we can rephrase the event so that it tells us more about the rules to pick. So, both marbles are red is actually the same as saying the first drawn is red and the second drawn is red. So now you see 2 events joined by the word and. According to the probability rules, it can be calculated using the multiplication rule. Now I'm going to go ahead and find the probability of drawing my first red. That is simple enough. So the answer will be 3 out of 7. Then I need to find the probability of drawing the second red. In the problem, it says the drawing is done without replacement, which means the first marble drawn is not being put back. That is going to affect how we calculate the probability the second red marble. Actually, the probability of drawing the second marble becomes 2 out of 6, simply because now we only have 2 red marbles left in the remaining 6 marbles. Now we are ready to do some calculations. So the probability of both marbles are red is the probability of drawing the first red marble times the probability of drawing the second red marble. The answer is 1 over 7 or 0.1429. The rule we are using is the multiplication rule for dependent events. Since drawing the first red marble affects the probability of drawing the second red marble, we see these 2 events are dependent. Here comes the definition of dependent events. 2 events are dependent if the occurrence of one event affects the probability of the occurrence of the other event. However, this definition is not a cut and dry definition. We will come back and discuss this in a little bit. Now let's look at the formula for multiplication rule when we have dependent events. It writes probability of event E and event F equals probability of E times probability of F given E, where the notation probability of F given E is used to denote the probability of F given the occurrence of E. It is called conditional probability of F given E. As you have noted, in the calculation of the probability that both marbles are red, we really should use the conditional probability notation when we calculate the probability of the second red. Remember, I said we're going to go back to the definition of dependent event. Here we go. But before I do that, let's look at another example. 2 marbles are drawn randomly from a bag of 300 red and 400 blue. It's done sequentially without replacement. So what is the probability both are red? You might be wondering, isn't this the same problem we have been worked on, just with different numbers? Then shouldn't we just do the same kind of thing as we did for the other problem? You are absolutely right. Now let's look at the probabilities of the same event. So probability of drawing the first red is 300 divided 700, so roughly 0.429 if expressed as decimal. Then probability of drawing the second red marble is 299 divided 699 and roughly 0.428. So these 2 events are dependent according to the definition of dependent events. However, if you examine these 2 probabilities, you may have noticed they are very close. So although the probability of drawing the second red marble is affected by the occurrence of drawing the first red marble, the change is very small and can be ignored. So in this case, we can actually consider these 2 events as independent. So the rule of thumb is If small samples are drawn from large populations, then each draw can be considered as independent. So now let's calculate the probability of both read. The true answer is 0.1833. When we treat the first read and the second read as independent event, an approximation of the probability of both are read is 0.1837, which is pretty close to the true answer. Therefore, when small samples are drawn from big populations, we simply treat each individual outcomes as independent events. Now, try a couple problems on your own and see if you really get it.